Welcome to this lecture about mixed air-water systems and readjustment. Readjusting means providing an additional way of controlling a room temperature at room level, opposite to controlling it solely on a central way, like in an air handling unit. But let's look first at mixed systems. In these systems, the hygienic air is supplied mechanically and is heated or cooled in an air handling unit, bringing this way a part of the needed heat and cold at room level. The remaining part is done by a water system. This saves a lot of duct space in the building. You see on the slide left a heating mode and right a cooling mode. So, look on the left, the total heating load is partly covered by heated ventilation air coming from the AHU and partly by a hydronic heating systems referred as Q heating 2 on the slide. As for cooling, look on the right, that's exactly the same. Mechanical return exhaust ventilation, like on this picture, allows for heat recovery between indoor and outdoor air, but is not strictly needed. Natural exhaust could also be applied as well. This system is currently applied a lot in new built houses in European countries in heating mode. It is quite standard. For houses, the air handling unit is a small one consisting of only a heat recovery heat exchanger and sometimes a small heater, as we will see later. There are many variations possible between the all-air system and the hydronic one. Hydronic is just another word for a water system, I remind you. The air system can be designed larger or smaller, just like the hydronic system, but of course in opposite direction in order to provide the total quantity of heat and cold needed. In another lecture, we described how zoned HVAC helps with a better control of ventilation, temperature and energy usage at zone level. The room hydronic system helps to control even more at room level this time. In a fully centralized air system of a certain zone, heat and cold are brought with identical temperatures to each room, and there is no control of the indoor climate at room level. As you may know from the course on health and comfort, being in control is a main source of people's satisfaction with their indoor environment. So even in an all-air system, some room control capabilities are preferred. This room control, when combined with a central system, is called readjusting. Let's make a non-exhaustive inventory of these systems and start with a common house system in European countries using a room that you see on the left. On the right we have the technical room located on the roof or the basement, for instance. There is natural ventilation and a radiator connected to the central heat generator, generally a gas or wood pellet boiler, generating hot water that is circulated to the radiator, in which it cools down and then goes back to the boiler in a closed loop. Nowadays, heat pumps are also used more and more because of their high efficiency. When district heating is applied, the central heat generator is just a heat exchanger connected to the outdoor heat grid. Observe the valve. The radiators can mostly be controlled at room level. Very often, there is also a room thermostat telling the heat generator when to produce heat and when to stop. In more modern systems, there is a mechanical exhaust and supply ventilation system with a heat recovery heat exchanger between the supply and the return. This is a kind of basic air handling unit. The preheated air is supplied to the room where it is further heated by the radiator. In general, there is also some possibilities to adjust the airflow rates. See the damper here in the return pipe of the air above. There is also a bypass. If it is hot, the air does not need to be preheated because it is already warm outdoor and indoor. Then it can be bypassed, and it can be bypassed by the heat. It can bypass the heat recovery heat exchanger. When it comes to cooling, the simplest system is the so-called split unit, the most well-known air conditioner. You see it here above the window with a small blue line below indicating the drain. Don't forget about condensation on cold pipes and surfaces. The central cold generation on the right is also called the outdoor unit, as it is often placed on the roof or the outdoor facade. Or there is a unit for each room, like on the picture above. It is a chiller, also called cooling machine or reversible heat pump. It can also be a heat exchanger connected to district cooling or to a duct to the ground or a river, the sea, etc. The chilled water is brought to the room unit through piping and then returned to the chiller to be cooled again. These chilled water ducts must be properly insulated with vapor-tight insulation to avoid condensation on the pipes. In this system, natural ventilation is used, meaning that you must open the window to get enough hygienic air. And of course, here too, it is possible to apply mechanical supply and exhaust ventilation and to recover some cold from the indoor air when it is very warm outdoors. Here too, you see a bypass to the recovery heat exchanger and a drain, as cooling may mean condensation. Let's look now at the all-air system. In this system, there is no possibility to control the temperature at room level. The temperature and humidity are centrally controlled in the air handling unit, and the air is provided to the room at a preset temperature and humidity. In heating mode, a simple room temperature readjustment can be done by using an electrical heater like that. This heater is switched on or off with a room thermostat or a simple switch. In case of cooling, you really need to connect to the hydronic system of the chiller. There is no such a thing as a direct electrical cooling. There is always a cooling machine. So it would look much more like that. Here too, there is a thermostat or a switch allowing to control the cooler in the room. As an alternative, it is possible to combine heating and cooling readjustment, and instead of placing it on the wall, you can also place it in the suspended ceiling that we are already using for the return air. And of course, all water pipes are placed on the walls or hidden in it, not like in my drawing. Here too, the control is by a switch or a thermostat. And as an alternative, you may also prefer this configuration with a radiator below on the left and a cooler above. In case of floor heating, the configuration would look like this one. Heating is done by the hydronic system and by the AHU, while cooling takes place only through the air handling unit. In dry climates, it may also be possible to use floor cooling, which is not shown in this figure. A solution used quite often in office buildings is the so-called fan coil unit. You can find it in two different types. Fresh air is supplied to the room through an opening in the wall on the left and the ventilator of the fan coil unit. The hydronic heating and cooling systems are connected to the fan coil and heat or cool the air before it is ventilated into the room. Note that this is an all-air system, and as such the supply airflow rate must be large enough to provide the heating and cooling demand. So the airflow rates will be much higher than with hygienic airflow rates only. There are also alternatives where the supply air is centrally pumped and then distributed to each fan coil unit. The advantage is that it allows for heat recovery, by which lower supply airflow rates can be used. Finally, we have to talk about the induction unit. Induction units allow for large heating and cooling powers. There is no fan in the unit, but a nozzle producing a jet at high velocity. Because the velocity is high at the outlet, the static pressure is low close to the unit. The jet is propelled far into the room, and as the jet velocity decreases when the air mixes with room air, the static pressure increases, inducing a high pressure at the other side of the room, and this in turn induces air movement back to the low pressure at the induction unit side. Because the room air is circulating all time to the unit, it can be easily cooled or heated, and only hygienic airflow rates are needed. The induction unit therefore saves energy in comparison with the fan coil units. However, as we have learned from the COVID-19 pandemic, they also cause many problems as air pollutants are not immediately exhausted through the return valve, but undergo many cycles in the room and are moved from one location to the other within the room. It is therefore not recommended to use them. In this lecture, an inventory of diverse configurations of mixed hydronic and air systems was given. It was shown how they help with controlling the indoor climate at room level. Thank you very much for your attention. Goodbye.